Hello, everyone. Welcome to Lesson C5 on subatomic particles. Now, just a little bit of review to start here. First of all, there are particles, and they come in compounds and elements, right? And compounds are made up of more than one type of atom, where elements are made up of one type of atom. And so what we're really talking about is elements. When we talk about subatomic particles, we talk about really what makes up atoms. It's a basic building block of all matter, and it's made up of three parts that we call the subatomic particles, which means less than atomic or smaller than the atom. First one is the proton. Now, the proton has a very dense center in the nucleus of the atom, and that's where the protons are found. They have a charge of +1, and they have an atomic mass of 1. Now, this is the equivalent of 1.67 times 10 to the negative 27 kilograms if you're doing it by kilograms, but that we just call it an atomic mass of 1 or an atomic mass unit. Now, the atomic number of the element equals the number of protons a particular atom has. So if we take a look, for example, at oxygen, oxygen is atomic number 8 on the periodic table, and therefore it has 8 protons. Sometimes we will symbolize it just like this with an 8p plus, because that's just 8 protons positive because it has, again, that +1 charge. Neutrons are also found in the nucleus, but they have a neutral charge, meaning a charge of 0. The atomic mass is also 1, meaning 1.67 times 10 to the negative 27 kilograms. But to figure out how many neutrons it has, we use a rounded atomic mass and we minus the atomic numbers. So, for example, if we take a look at let's say lithium. Lithium has an atomic mass that rounds to 7. It's like 6.9. And we're going to subtract 3 because that's the atomic number. This is the mass. This is the atomic number, meaning how many protons it has. And so you're left with 4 neutrons. And neutrons, we shorthand it with an N0. The electrons. This has found in the outer edge in the shells of the atom, has a -1 charge, so equal but opposite to the proton, and it has an atomic mass of 1,836, or if you put that in kilograms, it's 9.11 times 10 to the negative 31 kilograms. And in an atom, the protons and electrons are going to be the same. So if, again, we take a look at our oxygen example, it had 8 protons. Therefore, it will also have 8 electrons in an uncharged atom. I really like the way that an old 70s television show described that, and so we're going to take a look at that now. Oh, before we do that, if you add or remove a proton from an atom, it just makes it into a new kind of atom because the number of protons is kind of what gives it its defining characteristics. So if you were to take lead and subtract some protons from it, you would get a different type of atom. If you add or remove a neutron, you just make it what's called an isotope, right? It becomes a little bit heavier or a little bit lighter, but it's still the same. And if you add or remove an electron, it makes it what's called an ion, and that's just a charged atom, right? So the term isotope or ion are a couple of terms that you will need to know in future years. It's something that kind of comes up, but is for this course at this time is not something that we have to have memorized.
I can give you the basics of the atom in 2 minutes. You'll understand it perfectly and remember it for months.
2 minutes? You crazy, you know that?
If I can teach you about the atom in 2 minutes, will you go back to school and finish out the year? How about it, huh? Come on, you're a betting man. How about it, Arnold?
Yeah. Yeah, okay, sure. You got it.
I got your word.
Yeah, you got my word. In 2 minutes.
We got a deal.
Yeah, we got a deal.
All right, sit down.
Okay.
Okay. There are 3 gangs on the street, right?
Yeah, 3 gangs.
And this right here is the territory. Now, here is the neighborhood. Got that?
Yeah.
And right in the middle of this neighborhood is a gang called the New Boys.
Yeah, the New Boys. Good name.
Okay. Out here on the outside of the neighborhood, on the edge of the neighborhood, is another gang. You know, these are real negative dudes, really negative, right?
Right.
Now, they call themselves the elected ones.
All right, the elected.
You got that? Really negative. They don't like nothing, see?
Right.
Now, they all the time out here circling around the neighborhood, just circling, you know? Checking out the New Boys. Now, the New Boys see this, and they get, they figure there's something wrong here, so they make a deal with another gang. A gang of very happy-go-lucky guys. They call themselves the Pros. The Pros. Now, the Pros are very positive cats. You can see they got all the good-looking women, right?
Yeah.
Right. See, now the Pros and the elected ones, the interesting thing, they hate each other. So much so that they keep the same number of members in the gang, just in case, you dig?
Right.
So if I got 10 elected ones, how many Pros do I have?
10.
All right. Now, how many gangs do I have?
3.
Name them.
The New Boys, the elected ones, and the Pros.
All right. Who's here?
The elected ones?
All right. Now, what are they, negative?
Yeah, negative.
All right. Now, who's positive?
The Pros, and you're running out of time.
All right. Now, you see right here, the Pros and the New Boys, they call their hangout the nucleus. Yeah. Now, see, that's a real tough word. It's Latin. But I kind of think it's Swahili, and it means center.
Yeah? What is it?
It's nucleus. Say it.
Nucleus. Is that really African?
Say it.
Nucleus.
You got it?
Yeah.
All right. Give you another Swahili word. It's tron. It means dude.
Yeah, Tron. Dude.
All these gangs like that name so well that they all decide to use it. For instance, the Pros right here in the middle start calling themselves the Protons. And the New Boys, well, they start calling themselves the Neutrons. And out here on the edge here, the elected ones, they start calling themselves the
The electrons, the protons, and the neutrons.
Yeah. And all this right here, this is the neighborhood. This is block after block of nothing. You understand block after block of nothing, don't you?
Yeah, I know all about that. And your time is up, Professor DJ.
Good. I was finished anyway. Now you go on back to school, man.
School? Man, all I know about is a bunch of damn gangs that live in a round neighborhood.
Arnold, that's the atom. That's it, man. That's it. What's this right here? Huh?
Protons and neutrons.
All right, and they call this the what?
Nucleus.
All right, what are these guys up here?
Electrons.
Are they negative or positive?
Negative.
And how do they move?
Round and round.
And if I got 2 of them, how many protons do I have?
2.
Now, protons negative or positive?
Positive.
All right, and what's all this right here?
Oh, that's the neighborhood.
Which is?
Nothing.
You got it, man. You get an A.
So, if we take a look at how many of each, again, you're going to be referring to the atomic number for the number of protons. And we're going to be taking a look here at the atomic mass, and we'll subtract the atomic number to get the number of neutrons. Now, because this atomic mass is a rounded number, it takes kind of like an average of all of those isotopes, all the heavy ones and all the light ones and whatnot. We just use a rounded atomic mass in order to get a common amount of neutrons. So if we take a look at this here, this is their key within our periodic table. We got an atomic mass of 56, that's rounded, minus 26 protons, that gets you 30 neutrons. 26 being the atomic number means we got 26 protons and 26 electrons. Now, if we were to take these elements and try to come up with an equation for them, most of them are pretty standard. However, there are 9 of which that come in groups when we take a look at the elements. And that's hydrogen, fluorine, iodine, oxygen, chlorine, phosphorus, nitrogen, bromine, and sulfur. Now, the way I was told about this is I bring clay for our new house. And those are all our twos. I bring clay for our new house with 4 paving stones and 8 steps. Just a little anagram to kind of remember that by. So if we take a look at the examples that we have on in our notes here, chlorine, rounded atomic mass is only 35. So 35 minus 17 gets you 18 neutrons. Because that atomic number is 17, you've got 17 protons and 17 electrons. In the case of zirconium, we've got a rounded mass of 91 minus 40 as your atomic number means that you've got 51 neutrons. The atomic number being 40 means you got 40 protons and 40 electrons. On page 12, we've got this example with chromium. Pause the video, see if you can figure out how many protons, neutrons, electrons it has, and then unpause, see if you're good. And when you calculated the neutrons, you should have got 28 with 24 protons and, oh, my mistake here, 24 electrons. Try it now with gold. Give this one a try. Taking the rounded atomic mass with gold here of 197 minus 79, the atomic mass gets you 118. So 118 neutrons, 79 protons and electrons. Give this third one a try here. Pause the video again. Okay, and you should have found 31 neutrons, 28 protons, 28 electrons. So if we were to draw a diagram of the beryllium atom, we see that it's got mass of 9, 4, which means this would be 9 minus 4, or 5 neutrons. It will also have 4 protons and 4 electrons. Now we're just going to do a Rutherford diagram of this, but in the nucleus we're going to have 4 protons, put in 5 neutrons, in and around, and that is my nucleus with the 4 protons and 5 neutrons. And then we're going to put the electrons way out here. And I know this is not to size, but that's okay. It's just a diagram. And we've got these spinning around the outside here. Okay. Now, if carbon were to have 2 additional neutrons, how heavy would it be? Well, carbon normally has 6 neutrons, so we add 2 neutrons, each with a mass of 12, and so it would have a mass of 14. That's 12, its average mass, plus 2 equals 14. And this is just a heavy isotope. It's still carbon, it's just carbon that has a mass of 14. Now, if the nitrogen atom were to gain 3 electrons, what charge would it have? Well, because electrons are negative, this would have a charge of -3, and therefore is a negative ion, a charged atom. It's still going to be nitrogen in this case, but have a charge of -3 because it's got those extra 3 electrons. If we're to give a chemical formula for each of these, well, we have to again remember I bring clay for our new house with 4 paving stones and 8 steps. So hydrogen is one of those 2. Gold is AU, no little pair here. It's a solo one. Fluorine is one of those ones we need to memorize, as is sulfur. Magnesium is not one of the 9 we memorized, so it's a solo, as is carbon. But phosphorus is one of the ones we have to have memorized. And again, I bring clay for our new house with 4 paving stones and 8 steps. And so we're the first 7 there in that anagram are the doubles. That's it. Thanks for watching. Have a great day.